Yeah, hello friends. So, in this lecture we will learn the implementation of linear regression in Python. So, first we will take an example of simple linear regression where we are having one independent variable and in the second case we will take an example where we are having multiple uh, independent variables, means our dependent variable is depending on more than one independent variable, and then we will also see an example of polynomial regression. So, we will make use of sklearn.linearmodel.linear regression class for implementing all these examples. So, let me come to our first example where we are having ours as the independent variable. So, your score is a function of hours plus some error. So, now I have to fit a linear regression model between hours and score. So, what it will be? I will write score equals to a naught plus a 1 times hours. Now, data is given for like 28 students, the hours they are studying and their corresponding scores. So, based on this data I have to fit this simple linear regression model. So, let me take score as y, then it will become y equals to a naught plus a 1, and if I write hours as x. So, this is the simplest example of linear regression. So, now let us learn how to fit this model in sklearn.linearmodel.linear regression class of Python. So, what we will do? First of all, we will import numpy as np for array type utility. I will also import pandas as pd for data frames. I will also import matplotlib .pyplot class for plotting the results and data. So, let me run this, and while it is running let me import my data. So, loading data. So, for that I will use the function So, for that I will use the function from Google Colab, since I am using this import files, and then uploaded equals to files dot upload. So, you can use any other process also for reading your data from the local computer. So, now I can choose the file is on desktop, and here it is student dot underscore dot csv. So, now this file have been saved in my Google Colab. Let me read it. Here I will make use of pd dot read underscore csv and the file name student underscore scores, and then I will see the shape of this data. So, you can see there are total 25 rows and 2 columns. Let me check some of the row of this data using simple head command. So, you can see this data. So, first column I am having number of hours, and in second column I am having corresponding scores. You can see various parameter of this just by running the command. score dot describe this function if you use on the object score. You can see the count is 25. So, total 25 samples, mean of hours is 5.01, whereas the mean of score is 53.56. Standard deviation of hours is 2.52, whereas standard deviation of score is 27.07, minimum 25% quartile and so on. All those data you can see. Now, what we will do? We will plot this data. So, I will plot this one using score dot plot, and then I will be having x equals to hours, and then y is my the dependent variable is nothing scores of the students, and then style of each data point, let us take simply O. And then you will be having plt dot show for this particular plot. Yeah, so you can see on the x axis I am having hours, on the y axis I am having score, and these are these 25 data points. Now, my objective is to fit a linear regression model using this data, means I have to find out the best fit line for this data. You can see the data is okay, but I am having one outlier like this, where when the number of hours is 5, but one particular student is having very good score when compared to other neighborhood data. Okay, no problem, we will take it into consideration. Now, I will prepare my data. So, I am taking x equals to score dot I log, and in this I will having the first column, that is the hours column. So, I can have like this dot values, I will convert it in numeric values, and then y will become the second column. So, it means all row and second column, because first column is 0 column, and that dot values. Okay. So, I can run it. Yeah. Now, I am having independent variable as column x and dependent variable as column y. Now, what I will do? I will make an object of the linear regression class. So, first I will import from scalar dot linear models I will import linear regression. So, this class I have imported. Now, I will define an object of this class, let me say rig. So, this is I have created an object, and then I will be having my fit function on this object reg dot fit x y. So, let me run it. Yeah. So, I have done the fitting of my data. Let me print parameters, means what is my slope and y intercept. So, for that you can simply print the model is fitted model is rig dot intercept. So, it is 4.70, and if you print the coefficient. So, you can use the command print model is reg dot coefficient. So, COEF underscore for coefficient. Yeah, it is 9.74 something 75 around. So, now my model is y equals to 4.70 plus 9.74 times x. This is the line, or in other way score equals to 4.70 plus 9.748 times number of powers. So, this is my linear model which I have obtained using this fitting. Now, let me find out the new value of y using this model to calculate the residual error. So, I can use the function predict here, and I will again predict all x value, and then I will be having this y predict. So, let me show you the actual value and the value after this prediction using the model. So, for that I will create a data frame pd dot data frame, and then I will be having my actual value. So, actual value are nothing just your y, and then predicted one using the linear regression model, and this is nothing just your y underscore pred. Okay, so, let me try to run it. So, it is running. So, let me show it. So, I am showing this data frame to you. Yeah, so, you can see for all 25 students starting from 0. So, first one is having actual score 21, from my model it is coming 29.07. The second one is having 47, it is coming 54.41 and so on. So, you can compare all these values, but in concept lecture I have told you some measure. One is mean square error, another one is r square. So, let me calculate those also. So, print, before that let me import these metric. So, sklearn dot metric, I will import mean square error, and then I will also import R2 score. So, let me import these utility matrix, sorry, it will be matrix, not metric. I think it should run now, yeah. So, I have imported these utility. Now, let me use them. So, first I will calculate print mean square error. So, print mean, or let me write in short MSC, and it equals to, so let me write some space, and then I can have my result. So, result will be mean square error, and between what, y and predicted y, means actual y and predicted y. And so, let me try to run it. Yeah, so mean square error is 121.86. Similarly, I can calculate my R2 score. So, let me calculate here. So, R2 score or R square score is, just change the function, and function is R2 score. So, let me print it. So, R2 score is 0.83 and mean square error is 121.86. Let me also plot the data and fitted function. So, for that let me perform a scatter plot of original data. So, that is of x y, and let me take color as black. And then I will be having the plot of my result, that is x and y predicted one, and then I will be having color as, let me take color as blue, and the line width equals to, let me take it 2, and then plt dot show. No, it should be capital X, sorry. Yeah, so this is the result. So, all black dots are original data, and this is the best fitted line among this data using least square or linear regression, whatever you want to say. So, this is my first example. Now, in this example I have taken only one independent variable, that is hours. Now, let me take another example in which I will take more than one independent variable. Yeah, so I will explain this multiple linear regression example here when you are having more than one independent variables. So, like any other implementation, in first cell I am importing my utilities pandas, numpy, matplotlib and so on. Then in the second cell, like the earlier code, I am importing my data set. So for that let me run it, first cell and then the second cell. So it is having investment and profit of 50 startup at USA. So let me go to data set, and here let me choose my file startup.csv. Let me read it using pd.read_csv. So you can see now your data. So here I am having 3 input variables. One is R&D spend in the first column. So I am having data of 50 startups at USA. In first column, what amount they are spending in research and development. In second column, what these startups are spending on administration, and third column is what they are spending on marketing and advertising. So these are their spending and the expenditures, and the fourth column is profit. So here now profit is my dependent variable, and this profit will depend on all these independent variables. So I can take this example as profit equals to y. So y equals to alpha 0 plus alpha 1 times R&D spend plus alpha 2 times administration plus alpha 3 times marketing spend. So y equals to alpha 0 plus alpha 1 x 1 plus alpha 2 x 2 plus alpha 3 x 3. So let me prepare my data. So for reading this data, after reading I am assigning to 2-dimensional array x, in which I am dropping the last column, that is your profit, and this profit column I am saving it as a y variable, which is 1-dimensional array. So x is 50 by 3, 50 startup data with 3 columns, marketing, R&D and active expenditures and y is profit. So, let me print. So, you can see these are your x now, and then we will be having y column separately. Now, what I will do, since I am having 50 data points, I will divide this data into two subsets, one for training and another one for testing. So, I will make use of a function of sklearn dot model selection, and from there I will import train test split, and then as I told you, I will divide into two subsets, one is training data, another one is testing data. So, x train x test, y train y test equals to this data. Here what I am doing, my testing data size is 20%. So, 10 points I am taking for testing, whereas 40 points I am taking for fitting my multiple regression model. So, let me run it. Yeah. Now, whether you are using simple regression, linear regression means with one independent variable or multiple independent variable, the syntax for modeling your estimator, making your estimator will be same. You will import linear regression class from sklearn.linear model, you will create an object of this class and you will make use of fit function on that object. So, let me do it, it has been trained. Now, let me print coefficients like the last code. So, coefficient is, that is profit equals to 42,989.0081 plus 0.7788 times R&D spend plus 0.0293 times the administrative expenditure plus 0.034 times marketing expenditure. Making the prediction. So, please note, in earlier case I have fitted my model using x and I have made my prediction also, but here I am making prediction on unseen data, means which I have not used for in fitting, that is my testing data. So, now I am printing the actual y for testing data and predicted y. So, let me print it. So, you can see these values, they are quite close. Let me also see the coefficients. So, these are the coefficient, mean square error is of this order here and R2 score is 0.94, which is quite good. Let me plot also the data, because here I am having 3 independent variables and one depending variable. So, if I take this depending variable profit on the y axis, I can take only out of those 3 independent variables on the x axis. So, let me plot a graph where I am having actual values and predicted values, and that graph is between administration expenditure versus profit. So, let me plot it using the same command which I have used in earlier code, and you can see here. The blue one is predicted one, where is as black one is the actual one. So, you can see in these two cases, when your administrative expenditure are quite high, they are almost overlapping to each other. But when administrative expenditure is low, in that case there are some big residual error or some error, okay. But it happens, I cannot fit my model exactly having no error for each and every data sample. So, this is my second model in which I have taken a multiple regression model. Similarly, like here I have taken administration, you can take R&D expenditure or marketing expenditure also. So, for example, in case of R&D expenditure, the plot will be like this. Okay. So, now we have covered two examples. In first example, we have taken simple linear regression, and in the second example, we have taken multiple linear regression. Now let me take one more example of polynomial regression. Okay. So, in polynomial regression, I am making use of the same data which we have seen in concept class. So, here I am importing plotting libraries, NumPy, and then metrics like R2 score and mean square error. I am having x data, which is number of days, means 1 day, 2 day, 3 days and so on, 1 to 15 days, and on the y axis I am having the weight of onion bulbs. So, after 1 day weight is 16.02, after 2 day it is 33.83 and so on. So, for the polynomial fitting, I can simply use the NumPy utility, that is poly1d. So, my model, which is my polynomial fitting model, polynomial model, is numpy dot poly1d and then numpy dot polyfit on x y, and here you will give the degree of the fitting. So, if you will give it y equals means 1, it will be linear model. If you will give it 2, it will become y equals to a naught plus a 1 x plus a 2 x square. Similarly, if you will give any value k, it will be a k degree polynomial, in x. And then I am using these lines for plotting. I am making the equal space line between 1 to 100, 1 to 15, in this case 100 equal space points, equally spaced grid, and then I am plotting my data on it. So, let me run with linear model. So, I am taking it 1. So, it means y equals to a naught plus a 1 times x, or in other way the bulb weight equals to a naught plus a 1 times number of days. So, let me run it. Yeah. So, this is the linear model where these blue dots are the original data and this blue line, solid line, is the fitted one. Here R2 score is 0.91 and mean square error is 6811.63. Let me make it the 2 degree polynomial. So, result will be like this. So, you can see here the curve is going more closer to my actual data points. R2 score is 0.95, whereas mean square error is 3808.64. Let me take 3 degree curve here. We can run this simulation. When I am having 3 degree curve, you can notice the curve is even more closer now. R2 score is 0.98 and the mean square error reduced to 1247. Similarly, you can take, let us say, 5 degree curve. Yeah, so you can see now my R2 score is 1 and mean square error is 268.74. So, when I reach here, I am having this perfect fitting. If I will take higher degree model than this, then I may be having overfitting. Overfitting means my curve is having less error or very small error for this data, but when I will go for prediction or generalization for any other value, like I am having value for 12, 13, 14, 15, but if someone asks me, okay, what will be the value after 14.5 days, that value I do not know. So, that value I will calculate according to this curve, according to this polynomial model, fitted model, and there I may get error. In this case there is no problem, but suppose I am taking it 12, very high model. So, certainly for this data, yeah. So, when I am having 12-degree curve, you can see my error is even more less, 91.53. But what you can see, when I am checking the weight after 14.5 days, you can see I will be having some value here, which is even less than 13, 12, 14 and so on, which is not a correct value. It should come somewhere here, but this much error I am getting. So, this is the disadvantage. This is called overfitting. Training error is very small, but it is having poor generalization, poor prediction. Okay. So, with this we have seen three implementation. One is simple linear regression, another one is multiple linear regression, and the third one is polynomial regression. So, let me close this lecture now. Thank you very much.